We from Group 2 will show the demonstration of a full-wave bridge rectifier. In this video, we will show you how the circuit works in 3 steps. First, we will look at the basic full-wave bridge rectifier. This is a full-wave bridge rectifier circuit. It consists of 4 diodes in bridge shapes to convert AC into DC voltage. The diodes allow the current to flow only in one direction, so the AC signal converts to DC signal but without ripple or peaks. Beside the 4 diodes in the circuit, there is also a 1 kilo ohm resistor, 2 multimeter to look at the voltage, 2 oscilloscope with 10 millisecond of the time per division, and 1 function generator. The function generator has 50 Hz frequency, 10 volt amplitude, 0 volt DC offset, and the graph is shown in the sine function. During the simulation of the circuit, this is the output voltage we obtained after the rectifier. The graph shows a series of peaks, showing the voltage goes up and down in a pattern. These peaks representing the pulsating DC. It is a DC voltage, but it is not a smooth voltage. During both positive and negative parts of the AC signal, 2 diodes are conducted at a time, allowing current to flow in one direction, which gives the pulsating DC output. In the positive cycle, Diode 2 and Diode 3 are in forward biases, while Diode 1 and Diode 4 are in reverse biases. During the negative cycle, Diode 1 and Diode 4 are forward biases, while Diode 2 and Diode 3 are reverse biases. As we can see, the voltage value is going up, then drop and go up again. This is not a steady and smooth DC voltage yet. This is the result of the full-wave bridge rectifier. Then, we will add a filter to smooth out the output. Now, let's add a filter capacitor across the output. The blue little thing is the capacitor. The capacitor helps to smooth out the ripples in the pulsating DC voltage. It works by charging up when the voltage is high and discharging when the voltage drops and filling in the gaps. By this, the output is more stable but not so smooth. In this circuit, we are using a 25 microfarad capacitor. During the simulation, showing the new output with the capacitor added in the circuit. As we can see, the peaks are still there, but the output voltage is much smoother. The capacitor helps reduce the size of the ripples. The voltage does not drop as much between peaks, making it more like a steady DC voltage. However, it is still not a smooth DC voltage. We can see that the voltage now stays closer to the peak value, but with smaller fluctuations. This is the effect of the filter, in which it reduces the ripple in the output voltage and producing a smoother DC voltage. Finally, we added the voltage regulator for output stability. Lastly, let's add a voltage regulator. A voltage regulator keeps the output voltage constant even after changing the input voltage. This is the important step if you want a steady power supply in electronic devices. The regulator helps the voltage to stay at a specific value. Thus, we use a Zener diode as the voltage regulator in our circuit. To achieve the regulation of voltage, we connected the Zener diode in reverse bias and set the zener voltage to 1 volt. Since our voltage is 2.19 volts, it is bigger than 1 volt. The zener diode is operating in the breakdown region and the voltage is regulated to 1.13 volt. During the simulation, with the voltage regulator help, the output voltage becomes almost flat. The output voltage no longer fluctuates. It stays at a steady level even there are changes in input voltage. As we can see, the sine graph voltage stays at the same level. This flat line indicates that the function of the voltage regulator is by keeping the output voltage stable and reliable. The output voltage is the DC voltage that we need for most electronic applications. In summarization, we first demonstrate the basic full-wave bridge rectifier producing pulsating DC. Then we added a filter capacitor for smoothing out the output and reducing the ripples. Lastly, we added a voltage regulator produces a steady, smooth and flat output voltage. The process in power supplies provide reliable DC voltage.